Hello dear students, welcome to the series 1000 must solve problems for NEET in physics. Here we go. First question. A stone is released with zero velocity from the top of a tower, reaches ground in 4 seconds. The height of the tower is about. So they are asking us to calculate the height, means they are asking us to calculate the distance traveled. Okay, so initial velocity is 0, u is 0, and they are speaking about time, t is equal to 4 seconds. So definitely we should use the equation which connects x, u and t. So we can use x is equal to ut plus half a t square. Okay, now the height is always positive. Okay, so since u is equal to 0, okay, this ut term will become equal to 0. We'll write x is equal to half a t square. This implies, since the object is coming down, okay, the displacement is negative. So I'll write minus h is equal to half into acceleration due to gravity is always minus 10. Since it is coming down, all acceleration is always negative, into t square. Or I can write this as h is equal to 5 t square, or h is equal to 5 into t square. T square is 4 square. 4 square is 16. So 5 into 16. So therefore h is equal to 80 meters. Now you can use this equation here afterwards. Okay, if a ball is dropped from a height, okay, then if it takes time equal to t, then height can be directly calculated using the formula h is equal to 5 t square. Okay, so here in this problem, height of the tower is 80 meters. So option 3 is the correct one. Now we will move on to the next question. For the first half time, a car travels with velocity v1. And for the second half time, it travels with velocity v2. Okay, what is the average velocity of the car? 4 options are given. For the first half time, car travels with velocity v1, and for the second half time, it travels with velocity v2. Okay, we have to find the average velocity. Let us suppose that the car has traveled a distance is equal to x. Okay, for first half of the time, the car was moving with velocity v1. For the next half of the time, the car is moving with velocity v2. Only time is half, not the distance is half. Okay, now what is the average velocity? Now to calculate average velocity, you might be knowing the direct formula for this question. So it is v1 plus v2 by 2. It is arithmetic mean. But we will concentrate on how it comes. Okay, in the examination directly they can give the numbers for velocities directly. So that directly you have to use this equation. Now here we will see how to derive it. Average velocity is equal to total distance traveled divided by total time taken. Okay, so what is the total distance traveled? We know that total distance traveled is x. Okay, total distance traveled is x. What is total x? Or I can write this x as, okay, instead of writing this x, okay, velocity into time. Okay, total distance traveled, velocity, it travels with the velocity v1 for first half of the time, plus it travels with the velocity v2 for the next half of the time. So this is the velocity into time is distance. So this distance is equal to velocity into time. So when you add them, you are going to get x divided by total time taken. Total time taken is t by 2 plus t by 2. T by 2 plus t by 2 will be t. So what happens? See here, t by 2 is common. So therefore, I can take t by 2 out. T by 2 into v1 plus v2 divided by t by 2 plus t by 2 will be t. This t and t gets cancelled. So average velocity is equal to v1 plus v2 by 2. So here what we have to observe is when the time interval is half, if you find a problem like first half time, next half time, okay, then average velocity is just the arithmetic mean. So therefore you should go for v1 plus v2 divided by 2. Now we will go to the next question, question number 3. Okay, now here for first half distance, okay, car travels with velocity v1 and the second half is covered with velocity v2. Now what is the average velocity of the car? So again here, so this is the answer, we know it directly, but we will see how to derive it, because even if you forget the shortcut, okay, how to come to it, or if they have directly given the numerical values of v1 and v2, okay, directly we can use it, or if we forget the shortcut, then how to derive it, we will see. Average velocity is equal to total distance traveled divided by total time taken, total distance traveled divided by total time taken, total time, okay. So we will consider the same situation, okay. Say this is the distance traveled, say the total distance is x, okay. So this is first half of the distance, x by 2. This is the next half of the distance, x by 2, okay. First half of the distance is traveled with velocity v1, next half is traveled with velocity v2. So what is the total distance traveled? It is x by 2 plus x by 2 divided by total time. Time equal to, we know that I'll write here. So velocity equal to displacement by time, or speed equal to displacement by time. So this implies time is equal to distance by speed. Time equal to distance by speed. So what is this time here? Okay, distance divided by speed. So what is this time here? Okay, plus distance. What is distance? X by 2 divided by speed. Okay, v2. Now here what is x by 2 plus x by 2? X by 2 plus x by 2 will be equal to x divided by, I can take x by 2 common, okay, x by 2 common into 1 by v1 plus 1 by v2. So this x and x gets cancelled. This 2 will go and sit in the numerator. So 2 divided by, here you take LCM, what happens? v1 plus v2 divided by v1 v2. On simplifying further, average velocity will be equal to 2. So this is v1 v2, sorry, v1 plus v2 divided by v1 v2. Average velocity will be equal to 2 v1 v2 divided by v1 plus v2. Okay, so this is the correct answer. Now in the examination, what they will do, directly they will give, like, for the first half of the distance the car travels with a speed of 60 km per hour, and next half of the distance the car moves with a speed of 40 km per hour. What is average speed? Then what do you do? Directly in the place of v1 you put 60, in the place of v2 you put 40. Directly will get the answer. This can be used as a shortcut also. Now we will go to the next question, question number 4. The acceleration of a particle varies with time t as a is equal to bt plus c, where b and c are constants. What will be the velocity of particle which starts from rest after time t? Okay, so what they have given is acceleration of a particle varies with time, means now here we cannot use equations of motion, because the three equations of motion that we have studied, that is v equal to u plus at, x is equal to ut plus half at square, v square equal to u square plus 2ax, these are the equations of motion provided acceleration is constant. So now I cannot use this equation because they have directly given that acceleration is varying. So to find velocity, what I should do? So what they have given, acceleration, velocity is equal to, so integration of acceleration with respect to time, because so we know that if you have displacement, okay, if you differentiate displacement with respect to time, you are going to get velocity. If you differentiate velocity with respect to time, you get acceleration. If you integrate acceleration with respect to time, you get velocity, and if you integrate velocity with respect to time, you get displacement. So therefore, so to find velocity integrating acceleration with respect to time, or v is equal to, so what is a, what is acceleration? Acceleration is equal to, so bt plus c with respect to t. Okay, so it starts from rest. Okay, after some time t. Okay, at time t, so you integrate this between the limits 0 and t. What happens? V will be equal to, okay, bt square by 2. So b is a constant, it comes out. Okay, integration of t with respect to t is t square by 2. Okay, plus integration of a constant with respect to t is constant into t between the limits 0 and t. So what happened? So velocity will be equal to bt square by 2 plus ct, because since the lower limit is 0, just you have to substitute the upper limit, bt square by 2 plus ct. So it is second option. So now we will go to the next question, question number 5. A body is thrown upward from ground, covers equal distances in 4th and 7th second. What is the initial velocity of the body? What is the initial velocity with which the body was projected? Okay, so distance traveled in 4th is equal to distance traveled in 7th second, so that they have given. So definitely we have to use the formula distance traveled in nth second is equal to u plus a by 2 into 2n plus 1, 2n minus 1. Okay, now okay, what is the distance traveled in 4th second? We will see s4 is equal to initial velocity, we have to find out u. Okay, so what is a is minus 10, minus 10 by 2 is minus 5, minus 5 into 2 into, okay, what is n equal to 4, 2 into 4 minus 1. So s4 will be equal to u minus, okay, 2 into 4 is 8, 8 minus 1 is 7, 7 into 5 is 35. Okay, let me write this as equation number 1. Okay, now what is the distance traveled in 7th second? S7 will be equal to u, okay, plus a by 2 means minus 10 by 2 is minus 5, okay, into 2 into 7 minus 1, or S7 equal to u minus 2 into 7 is 14, 14 minus 1 is 13, 13 into 5 is 65. So this is my equation number 2. Now what we have to observe is, if the body is going only upwards, what happens? Velocity of the body, okay, or speed with which the body is going keeps on decreasing. Speed keeps on decreasing. So if the body is going only upwards, it is not possible for the body to cover equal distances in 4th and 7th second. Then what we should understand is, definitely during 4th second the object is going upwards, and during 7th second object is coming downwards. Okay, so here then what we'll do, S4 is taken as positive, S7 is taken as negative. Okay, now if you perform 1 plus 2, okay, 1 plus 2, what happens? 1 plus 2 gives S4 plus S7 minus S7 will be equal to 0, because in magnitude S4 is equal to S7 they have given. So u plus u will be 2u, okay, minus 35 plus minus 65 will be minus 100. What do you get? 2u equal to 100, or u is equal to 100 by 2 is equal to 50 meter per second. Or you can have a alternate method also. Okay, so somehow if you come to know that during 4th second object is going up, and during 7th second object is coming down, then you can conclude that definitely during 5th second object will be going up, and during 6th second object will be coming down. So therefore t is equal to 5 seconds is the time of maximum height. Okay, at time of maximum height, velocity will be equal to 0. So therefore I can use v equal to u plus at formula. So velocity will be equal to 0 if time is t maximum. What is t maximum? 5 seconds. So u minus a is 10, okay, t is 5. So from this diagram we came to know that at t is equal to 5 seconds it is at maximum height. At time of maximum height velocity is equal to 0. So now what we got? U is equal to 50 meter per second. Okay, now we will move on to the next question. Question number 6. A ball is thrown vertically upwards with a velocity of 25 meter per second. U is given. from the top of a tower of height 30 meter. How long will it travel before it hits the ground? Okay, so there is a tower. Height of the tower is 30 meters. A ball is thrown upwards with a speed of 25 meters per second. It goes up and hits the ground. Okay, after how long will it travel before it hits the ground? Means you have to calculate the time required for the ball to reach the ground. So here I can use the equation x is equal to ut plus half at square. Why I can use? Because displacement is given, initial velocity is given, acceleration is g itself, so only unknown is time. I can use this. Okay, so initially the ball is here, finally the ball is here. Now if I take this as a reference, the actual displacement is downward. So when the displacement is downward and effectively if the particle is going down, displacement is negative. So I can write minus 30 equal to u. U is 25 because the object is thrown up now. So it is plus 25 into t. So a is how much? A is minus 10. Minus 10 by 2 is minus 5. Minus 5 into t square. I'll rearrange it a little. So what happens? 5t square minus 25t minus 30 is equal to 0. I'll divide the entire equation by 5. Then what happens? T square minus 5t minus 6 is equal to 0. T square minus 6t plus t minus 6 is equal to 0. I have written minus 5t as minus 6t plus t. Here I'll take t out. Okay, t into t minus 6 plus 1 into t minus 6 is equal to 0. That means t minus 6 is equal to 0 or t plus 1 is equal to 0. So what does it mean? T is equal to 6 seconds or t is equal to minus 1 second. So this time cannot be negative. So t is equal to 6 seconds is the answer. Now we will go to the next question. Question number 7. If a ball is thrown vertically upwards with speed u, the distance covered during the last t seconds of ascent. Okay. So we have to calculate distance covered in last t seconds. For this we need to know one concept, that is distance traveled in last t seconds during ascent is equal to distance traveled in first t seconds during descent. So therefore, instead of calculating distance traveled in last t seconds during ascent, we will calculate distance traveled in first t seconds of descent. So what we will do, so x equal to ut plus half at square. Distance traveled in first t seconds means initial definitely u should be equal to 0 and the object is coming down. So in the place of x I'll write minus x is equal to half into, okay, acceleration is always negative, into t square. So this negative gets cancelled. X is equal to half gt square. So therefore distance traveled in last t seconds of ascent is equal to half gt square. Or what you can do is you can use the equation, x is equal to vt minus half at square. So how did we get this equation? Okay, so we have x is equal to ut plus half at square. Okay, so then we have from the equation v is equal to u plus at. Okay, v is equal to u plus at. Let me write an equation for u. So u is equal to v minus at. Okay, I'll substitute this here. What happens? X is equal to v minus at into t plus half a t square, or x will be equal to vt minus at square plus half at square. So on simplifying, what happens? Minus at square plus half at square will be vt minus half at square. Okay, So if final velocity is known, then you can use this equation. Okay, here we are asked to calculate distance covered during last t seconds, means at the end of the t seconds velocity is 0. Okay, so we know that final velocity is 0. So x will be equal to, so vt, since v is 0, this term is 0, minus half into minus g t square. This minus minus gets cancelled, so we got x is equal to half gt square. Okay, so one thing is you can use this equation, x is equal to vt minus half a t square, since final velocity is known to you. Otherwise you should remember the concept, distance traveled in last t seconds during ascent is equal to distance traveled in first t seconds during descent. Okay, now we will move on to the next concept, next problem. Problem number 8, a bus starts moving with acceleration 2 meter per second square. A cyclist 96 meters behind the bus starts simultaneous towards the bus at 20 meter per second. After what time will he be able to overtake the bus? Okay, so there is a track here. Bus starts moving, so with an acceleration of 2 meter per second square. There is a cyclist 96 meter behind the bus. There is a cyclist here, okay, who is 96 meters behind the bus. Okay. Starts simultaneous towards the bus with the 20 meter per second. He is coming with a speed of 20 meter per second. After what time will he be able to overtake the bus? Okay, now we will see. Let us suppose that this is the point. Okay, this is the point wherein cyclist overtakes the bus. Say at a time t, cyclist will overtake the bus. Okay, in that time t, what is the distance traveled by the cyclist? Okay, since the distance traveled by the velocity of the cyclist is 20 meter per second, means in 1 second he will travel 20 meter, in 2 seconds he will travel 40 meters, like that. So in t seconds he will travel a distance equal to 20 t. Okay, so from this reference point, where he will be, okay, at when the time is t seconds, okay, what is the position of the bus we will calculate. So distance traveled by the bus, okay, distance traveled by the bus is equal to, x is equal to ut plus half a t square. But you see, okay, bus starts moving, means initial velocity of the bus is 0. Okay, initial velocity of the bus is 0. Then acceleration of the bus is 2 meter per second square. So therefore half into 2 into t square, 2 gets cancelled. So therefore distance traveled by the bus is t square. In time t, distance traveled by the bus is t square. This is t square. Okay. Now with respect to this cyclist, so where is the bus? Bus is at a distance of 96 plus t square. Okay, so that 96 plus t square should be equal to distance traveled by the cyclist in time t, because at time t cyclist is overtaking the bus. So therefore I can write t square minus 20t plus 96 equal to 0. I can write this as t square minus 8t minus 12t plus 96 equal to 0, because minus 8 into minus 12 will be plus 96. Now what happens? T into t minus 8, okay, minus 12 into t minus 8 equal to 0. This implies t minus 8 equal to 0 or t minus 12 equal to 0. So t is equal to 8 seconds or t is equal to 12 seconds. So what does it mean? We got two answers. So this just means that, so first who has to overtake? Cyclist is behind na. Cyclist has to overtake the bus first. Okay, then after some time Since cyclist is moving with a constant speed, bus is accelerating. Accelerating means velocity of the bus is increasing. After some time, bus will again overtake the cyclist. Okay. So what does it mean? Cyclist will overtake the bus at t is equal to 8 seconds. Then later at t is equal to 12 seconds, bus will overtake the cyclist back. Okay. Now for this given question, after what time will he be able to overtake the bus? At 8 seconds. It is like you are moving in a bicycle. Here there is a car, okay, standing. The car just starts. In the beginning you will be able to overtake the car, but what happens after some time? Car is definitely going to overtake you. Next we will go to question number 9. A ball is dropped vertically from a height d above the ground. It hits the ground and bounces up vertically to a height d by 2. Neglecting the subsequent motion and air resistance, its velocity varies with the height above the ground as. So we have to draw the variation of velocity with distance. See, v square equal to u square plus 2ax. So initial velocity is 0 because the ball is dropped. You can see ball is dropped. Okay. So v square is proportional to x. V square is proportional to x means v should get a parabola. So in question option number 3, okay, straight line is there, so I can right away rule out this is not possible. Okay, then what you should observe is when the ball is falling down, the sign of velocity is negative. Okay, the ball bounces back and goes to some height. Here the velocity is positive, means velocity should be in both the quadrants. Okay, if the velocity is positive, it should be in first quadrant. If the velocity is negative, it should be in the second quadrant. So definitely second option is not possible, fourth option is not possible, because according to second option, whether the ball is coming down or going up, velocities are positive. In the fourth option, velocity is both times velocity is negative itself, so even fourth option is not possible. So we will carefully observe first option. Okay, so when the ball is falling down, okay, from a distance d, okay, ball is dropped from a distance d. When the distance from the ground is decreasing, velocity is increasing. See here, velocity is increasing, but velocity is increasing in the negative direction. Okay, and the variation of velocity and distance is parabola. Okay, it is right. So ball just hits the ground. Okay, ball just hits the ground, then suddenly it starts moving up. Suddenly the velocity is positive. Okay, velocity is positive. When the ball goes up, velocity decreases, but still it is positive and reaches a height equal to d by 2. So therefore first option is correct. Now we will go to the next question number 10. It is the easiest one. The displacement of a particle is represented by the following equation: x is equal to 3t cube plus 7t square plus 5t plus 8, where x is in meter and t is in seconds. Acceleration of the particle at t is equal to 1 second is. So x is 3t cube plus 7t square plus 5t plus 8. So what is acceleration? To find acceleration, you have to double differentiate this x. What is velocity? Velocity equal to dx by dt, that is equal to 3 into differentiation of t cube will be 3t square plus 7 into differentiation of t square should be 2t plus differentiation of 5 into differentiation of t, so that is equal to 1. Differentiation of a constant is 0, so you got velocity is equal to 9t square plus 14t plus 5. To find acceleration, we have to differentiate this velocity once again. So 9 into differentiation of t square is 2t plus 14 into differentiation of t is 1 plus differentiation of a constant is 0. So acceleration is equal to 18t plus 14. Okay, now we are asked to find out acceleration of the particle at t is equal to 1 second. So at t is equal to 1 second, so acceleration is equal to 18 into 1 plus 14, 18 into 1 plus 14, 18 plus 14 is 32 meter per second square. So therefore third option is correct.